Good evening, everybody. This is Mrs. Henry. Welcome to the last assignment for online learning. This is a review of scatter plots and data. Unless you're algebra, then this might be brand new to you. You do need to either print out this paper or you can grab some regular paper and jot down some notes. But somehow between the two, you do need to have some notes. Also, you might want to grab a calculator. You may need it later. Scatter plots and data, what we're looking at is we are looking at overall trends or patterns between two sets of numerical data. Let me try to get that in there. Or number data. Okay, the first type of association we're going to look at is positive. The sets of data move in the same direction. As one increases, the other also increases. Okay, so for instance, the number of hours a person works and the amount of money they earn. You would expect that the more hours a person works, the more money they will make. So as one increases, so does the other. You see this linear association, meaning that although the dots don't make a perfect line, you can see where you could impose a line in that graph. The second one is nonlinear, is kind of making a curve, okay? So anything that you could not put a line through it would be nonlinear, okay? Let's take a look at a negative association. Negative does not necessarily mean bad. It just means as one increases, the other decreases. Okay, so think about it this way. The number of hours that a person works and the amount of free time they have. Okay, so the more hours that you work, the less free time that you have. So if you work this many hours and you go up to the dots, that is the number of free time that they have. If they work more hours, you can see that the amount of free time is going to be a lot less. This one is also linear. You can see that you can kind of impose a line going that direction, negative sloping. Nonlinear, kind of doing a curve again. Okay. No association would be one set of data has no effect whatsoever on the other set of data. So using the number of hours a person works, let's think about the effect that would have on, I don't know, the length of their hair. Okay, that doesn't even make sense. So we would not expect an association between that. It's not that the more hours you work, the longer your hair is. Doesn't make sense. Okay? All right, let's look at trend lines. We're going to have to remember how to write an equation. Okay? So we have this scatter plot, and it's linear. That means that a straight line, like I did in the examples above, can be drawn to show the overall trend, and you can make predictions off of that trend. Okay. The equation for the trend line over here, notice that they put the trend line in for us already. When you put a trend line in some data, you want to get as many points above the line as you can below it, and possibly some points on the line as well. Okay, so in order to write the equation for that, remember slope-intercept form, where m is your slope and that's your intercept. That's the easy one to find. Your intercept's going to be right there at 20, so b is equal to 20. Okay, your slope, pick any two coordinates on that line, and I'm always looking for coordinates that cross at an intersection, like right here and right here. Okay, there's many of them that are on there. You can see that you can pick any of these points. Okay, I'm just going to look at the rise and the run over these 2 points right here. Okay, and if I look at the rise, it's going from 40 to 50, which is 10 units. My run is going over 1. Okay, so that's my slope right there, 10 over 1. Okay, and then I'm going to put that in my formula. Y equals m, which is 10 over 1, or just 10, x plus b, which is 20. That's my equation. We can use that equation to make predictions with numbers that are not on that line, like 10 or 12, or in this case, let's predict the value when x is 15. Okay, so we've got our equation of y equals 10x plus 20. Well, what is the value of y when x is 15? So y equals 10 times 15 plus 20. Okay, that's going to give us y equals 150 plus 20. Okay, so y is equal to 170. Okay. The next question says, using that same equation, let's predict the value of x when y is 120. Okay, our graph, you can see, only goes up to 100. Okay, let's see what it would be when y is 120. So I'm going to replace y with 120. I don't know what x is. Okay, but I can solve for x. I'm going to subtract 20 on each side. And divide by 10 on each side. So x is equal to 10. So the value of x is 10 when y is 120. Okay, I can make some good predictions. All right, then my favorite thing out of this whole unit is two-way tables and relative frequency. Okay, two-way tables are used to display categorical data. They show us that the frequency or number of times that something occurs. Okay, so basically you're just filling in the table. Then we have relative frequency, and we have to base that out of a total. Sometimes they just ask you a relative frequency in the form of a fraction. Other times you have to actually calculate that percentage. Most of the time you're going to see it as a percentage, so you might want to just put that in parentheses over there. Okay, so we have this table. We need to go ahead and add everything up so we can make some decisions based off of this table. So we have categories of ice cream or cake against male and female. So we have 14 males that prefer ice cream, 21 males prefer cake. How many total males do we have? Well, 14 plus 21 is 35. Okay, so I don't know how many females prefer ice cream, but I do know that 18 prefer cake, and there's a total of 37 females. So if I take 37, subtract 18, that's going to leave 19 that prefer ice cream. To double check that I'm correct, I'm going to add 14 and 19, make sure it's 33. Okay. To get my answer for cake, 21 plus 18, 39 total people like cake over ice cream. Okay. How many total people were surveyed? Well, that's going to be that total right here. 72 people were surveyed. All right, so we're going to need that, those figures to be able to answer these questions. Okay, of the females surveyed, the frequency of those who preferred ice cream is, okay, so of the females surveyed, you're only looking at females surveyed. The frequency of those who prefer ice cream is 19. Okay, so 19 preferred ice cream. Now, the next one is showing relative frequency. Remember what I said above. Relative frequency, you're going to have to compare it out of the total. Okay, and it's probably going to be a percentage, which, as you can see, there's a little percent sign there. Okay, so they're asking basically the same question. Of the females surveyed, we know there are 37 females surveyed. Their relative frequency of those who prefer ice cream is 19 out of 37. Okay, so that's the fraction. To change it to percent, you would take 19 and divide it by 37. Okay, and then convert it to a percentage. So I got 0.5135 and a whole bunch of other numbers. I'm going to change it to a percent, and it's just going to be about 51%. Okay, so if you don't have a calculator, chop down the tree. 19 divided by 37. Okay, or like I said, 19 divided by 37 is a little more than 51%. I hope that helps. Have a great evening. Enjoy your last